And in this movie, we are gonna talk about the functions. So, if you watched my previous movies, a couple movies, where we designed a very ugly app that just don't do anything, just displays a number multiplied by something on the screen, but I would call that as a pure entertainment and a little bit of the implementation of what we are learning so far. So in case you did focus a little bit out there, you might have seen that there was a word written as func and view did overload out there or view did load out there. So entire Swift is actually composed of variety of functions. And function is nothing. It's just a wrap-up of a couple of lines of code which are run whenever you call them. So it's just basically a wrap-up of a couple of lines of code. So let me bring my console here, which is a playground, and we're going to talk about the functions here. So if we talk about the technical terms, functions are self-contained chunk of codes that performs a specific task, whatever the task you're assigning to it. It's pretty easy, pretty simple. And entire Swift, most of the time you won't be writing much of the functions because most of the functionality like tapping on the screen or a button is being pushed, everything is being automatically done in the other libraries out there. But still, we should have a little bit of understanding how we can create our function, call them, and what are the technical jargon things going on behind the functions. So let's go ahead. In order to create a function, you just need a keyword func, and that's what they came up with. Okay, and in fact, I think this is cool. Func, very funky. And we can create something with the name of the function, then we give the name. Let's just say hello is the name of my function. Then always and always and always again, it's gonna follow up with a pair of parentheses. In the pair of parentheses, you just put out some parameters that you expect when somebody calls a function. These parameters need to be passed. For example, I just expect that it pass on the name of the function and it should be a string. And I always need to do type. I need to just confirm the type of the things which I'm expecting out there. And then I use a dash sign, and okay, it does something like this. Okay, then I need a dash sign and this arrow. This is actually a return type. So whatever the things you might be doing inside the function, in most of the cases, you'll be returning some value from the function, and you can return pretty much any value like integers, boolean, double. In this case, we are gonna just have a string. There we go. Now followed by a pair of curly braces. Inside this, you just write out whatever you need to write out. For example, let's write something. Let's just say let say, just a variable say, and the variable is gonna say welcome to my game, and then a space, and then just let's add a simple name here. So name of the person, whatever it's being passed on. Okay, so this sounds little cool, and what I'll do, I'll add a plus sign and one more exclamation here just to add up the things. But things are not done yet because our function is actually expecting something that is a return type. I do need to return something, so I'll be saying that please return let's return the say, and there we go. So we are returning the say here. Okay, that's cool, but how do we call this function? So let's just say I'll be using a print here, and the print statement, I'll call this function. So let's just say hello is being called, and name is there as the colon, but you need to pass on a string. So let's just pass a string and let's just call it something. So let's just say what should I call? Let's just say Sam, and there we go. So it says to me, welcome to my game, Sam, and let me add a comma here. It makes sense, but again, nothing much here. So this is a basic function that we have designed here. It's simply a name followed by a keyword func, then the name type here. You can have many arguments or nothing at all, and then the return type. Now let's add a few couple of things out there. Like for example, let me first recompile this, because this is actually a 2 lines of code, and I could have done something like a return, and it could have returned simply like something in this case, return this is returned. Oops. Okay, so this is return. And this works really great, but I haven't added anything out there from the name Sam. So what we can do, it is not always compulsory to add any arguments out there. You can just get rid of these arguments, and again it's gonna work really fine. So this is how it goes, and right now it just works really good, because since the function, at the time of the design of the function, we said that you should not expect any function, so that's why it's not expecting any function. Let me hit a Command Z a couple of times. There we go, back again. Now since our function actually says return something, that means we are giving this an arrow and a string. But yes, we can get rid of this as well. Like, let's just get rid of this. So now it's not gonna say return anything. In fact, let me just comment out this line for a moment, because I need that back. And let's just have a print and say something like print and return are two different things. And printing is actually just to print the things, and return just gets the thing, and later on you can just do calculation on it or perform further task on it, but printing just prints it out. So these are two different things. Obviously it's pretty obvious out here. So we can see that function can have parameter, can completely get rid of the parameters, can have return type, can get rid of these return types, and just like that, and they can return multiple values as well. So let's design a new code out there, a very simple one. So let me code this very quickly. So this is going to be a function. Oops, there we go, function, and let's call it as min max, a simple function that we are going to create. And this function is gonna have an array, so an array of an integer. So let's just call this is how we declare integer array, and this should expect multiple values out there. So we will have multiple return types from it, and the first one is gonna be the min, so it's gonna be an integer, and separated by comma we will have a max. So there we go, our max. Again, it would be integer. Okay, this looks good, pretty good to me. But what I have done here is actually I have used a tuples. Whenever you see these pair of parentheses, that means I'm trying to use a tuple. So if you need multiple return types, or you need to give multiple arguments, then you can use these guys. Now there is one more thing that you can have here, is a question mark, which is a sign of exception. Now simply it's an optional thing. Now whenever we put a question mark, that means optional, and we will talk about the optionals and the exclamatory mark in a full separate movie. Right now I can put it or can get rid of that, but right now I'm gonna just put it out there. Okay, so let's design a functionality for it. It's gonna be really quick. Okay, so this is a quick code that I've written here, and the code is actually highly inspired by the Swift original documentation, because I found this really a good example here. So what do we have here? Let me quickly explain to you. So this is a min-max function which expects an array of integer, and it returns a tuple that contains minimum and maximum value that are both integer types. First of all, it checks out if the array is empty. If it is empty, it just returns the nil. Then I have assumed that the first element is actually the minimum element, and the first element is of course the maximum element as well. And then I'm doing a rigorous checking for a loop that says if the value is actually less than my assumed value, then just assign that value into that. And that's a pretty simple logic. So I have assumed that the first element is the smallest, then I have compared every element. If I do found a smallest element than my assumed element, then I assign a value to it. And same goes in this if part as well. I have assumed that my assumed element is the maximum element. If this condition is wrong, then just switch the element to the current element, and I'm returning the values here. So this is good, and now I can use optional binding to check whether the version of my min-max array function returns the actual tuple or just nil. So let's use an optional bind checking. So if I do a if let, and this is the syntax, and let's just say bounds, and this is just a bound, and I'll use a min-max function out there. There we go, our min-max function, which expects an array. So let's pass on an array. So let's just say 4 comma 6 comma 7 comma -3 comma 6, or let's just say 5 and 9. Okay, just random guessing values. And then I can put these guys, the curly braces, and I can just print out the values. So there we go. And I'm gonna just say that I'll use, let's just say min value is, and then I'm gonna use this guys, and it's gonna say simply bounds dot min, and let's just say and max value is, then again I'm gonna use a slash these guys and bounds dot max. Okay, pretty simple, pretty easy. And let's just wait for a couple of seconds to run it. So we can see the minimum value is -3 and the maximum value is 9, and that's it. So it does really works good. So we have seen a couple of things here that I have used array.count. This is a common practice out there, and this is a simple logic. So we are not here to understand the data structure things, but yet it is a very bad checking that I've done. There are various other algorithms that I can apply, but I'm not bothered about them right now. And we have seen how tuples can work out, and similarly, which I have used, that I have returned the tuples, I can actually pass on the tuples as well. So this was a quick introduction about the functions.